Hey everybody, it's Mike here. Welcome to the channel. Well, today I'm addressing a question that I received from a student. And the question is, what's the difference between mass and weight? And how should I interpret that when running a simulation in Maya, right? Now, if you're working in Maya, then this might be a video for you. If you're not working in Maya at all and you just want to know what the difference is between weight and mass, then stick around, right? This could be interesting. Okay, so the confusion usually starts with the fact that people on planet Earth say, my weight is X amount of kilograms or pounds. Well, the thing is, kilograms is not an expression of weight, it's an expression of mass. But we never use that, and the reason why is because gravity on Earth is pretty constant, right? Technically speaking, if you want to say it correctly, you would say, oh, my mass is 80 kilograms, or you would have to say, my weight is 800 newtons, right? So mass is expressed in kilograms and weight is expressed in newtons. But the simple fact is people don't do that on planet Earth, right? Anyway, that's what we're going to be talking about. So I have this set up here. We got two spheres, right? And the one on the left has a mass of 1, right? So that could be 1 kilogram. The ball on the right has a mass of 1, so that could also be 1 kilogram. So they have an equal mass. Now let's look at the gravity that is affecting them on planet Earth. So the gravity for the ball on the left is 9.8, which stands for 9.8 meters per second square, and the one on the right is also 9.8 meters per second square. Well, what does that mean? Well, it means that if you drop an item on planet Earth, then the speed in which it falls down will be 9.8 meters per second, right? That's the acceleration. So with all the conditions being the same, the mass and the gravity and everything else, these balls should fall down with equal speed, right? So I'm just going to go to frame 1 here, and I'm going to play the simulation and see what happens. And as predicted, they fall at exactly the same rate, okay? All right, now to prove to you that mass is something very different than weight, what I'm going to do is I'm going to change the mass of the ball on the right-hand side. So we're going to go to ball on the right, and I'm going to increase that mass from 1 to 100. Okay, so now we both have the same gravity, but the one on the left has a mass of 1, the one on the right has a mass of 100. What do you think is going to happen? Okay, let's jump to frame 1 and let's hit play. They fall down with the exact same speed. And the reason for that is regardless of mass, objects in free fall have the same acceleration, which on planet Earth would be something like 9.8, right? So if gravity is that what affects your weight, if you will, right, then that should be a consideration. So what I'm going to do next is I'm going to change the mass back to 1 here. And instead of changing the mass, I'm just going to change the acceleration, okay? So the one on the left here, we're going to call that planet Earth, right? So planet Earth, we're going to go and look at the gravity, and that's 9.8 meters per second square. The one on the right, this guy, we're going to change that to the gravity setting that we find on the moon, which is 1.62 meters per second square, right? Now, with that set up, let's see what happens this time around. And keep in mind, the mass is identical, right? Let's hit play. So the mass is identical, the acceleration on planet Earth is much higher, therefore it falls faster, and on the moon it's much slower. If you've ever seen that footage of Neil Armstrong on the moon where he jumped up, it was kind of like he was somewhat floating, right? And that is related to the gravity. So his mass in kilograms didn't change, but his force compared to the surface he was walking on related to the local gravity changed, right? So yeah, that's what I want to explain. Hopefully it was clear, and if you want me to do more videos like this, please let me know. I'll happily do so, right? Thanks for watching. See you guys in the next one. Bye.